Hello everyone, this is a LabVIEW hands-on workshop, and I would like to say that this is a pre-recording for the 4th of October 2019 for the NI Academic and Industry Forum Singapore. My name is Alex C. I'm a senior lecturer and a deputy course chair at School of Engineering. I'm also been invited as a LabVIEW champion to carry out this LabVIEW hands-on workshop for this event. So maybe before I start, I would like to show you the event is called the NI Academic and Industry Forum Singapore. It will happen on the 4th of October 2019 as mentioned, from 9 to 5 at the Park Royal on Beach Road. So this is the venue for the event, right, in Singapore. And just to share that the agenda for the program for that day will be as follows. In particularly for myself, the LabVIEW hands-on workshop by the LabVIEW champion is from 9 to 9:40 a.m. as you can see on this screen here. And then you have the rest of the program for the rest of the day, as you can see. Okay, so I think in the afternoon they have two tracks. One is on the wireless research track, and also there is a energy and monitoring track, as you can see over here. Right, so without further ado, let me take you back to my recording here. Now, this recording will be break into two sections, where in the first part of the hands-on workshop, it will be more of a description of various things, such as what is LabVIEW and so on. So technically, this hands-on workshop is really for beginner LabVIEW users, rather than intermediate or more advanced LabVIEW users. So what is LabVIEW? I think LabVIEW, as we know, it stands for Laboratory Virtual Instruments Engineering Workbench. So basically it is a graphical programming platform which is widely used by engineers and scientists, and it has been around for quite a long time. So as you can see, LabVIEW, with the my first personal encounter with LabVIEW was about 22 years ago, when I was a PhD student reading for my PhD degree at UK. I was tasked to use, at that time, my professor is actually working on, and myself were working on a high voltage instrumentation project. So the idea was to be able to measure the space charge in the electrical insulation, in particular cross-linked polyethylene. So back then I was tasked to look at how to automate or using the LabVIEW software along with a suite of instruments, for example the LaCroix high channel oscilloscopes, back then, through the use of GPIB, general purpose interface bus. So my own experience was that with LabVIEW, it was able at that time to rapidly connect and configure instruments very quickly, because of the quite a variety or availability of third-party driver instruments, instrument drivers I mean. And also with LabVIEW, I found that it were able to acquire data. Basically, what we want was to acquire data, of course seamlessly integrating with hardware. That was quite an important point. Acquiring data followed by the analysis, processing, and then at the same time we also need to visualize and report our data. So I think in a nutshell, I think LabVIEW is a very pleasant software tool that will accelerate engineering development, in my own opinion. And besides that, you can quickly reuse some of the codes, libraries and scripts if you have some, which I will explain a little bit later. And also it has a rather beautiful graphical user interface, which is one of the plus point. And it can reduce so-called test development. Okay, and you can reuse a lot of the libraries as well, which is make it very nice tool to have. Now I think to begin, because as engineers and scientists, we tend to be able to break down a problem into bits and into parts, perhaps. So and generally, even for myself, when I encounter when I'm given a certain task, right, we tend to break down a complex system very quickly into small things like flow charts, which is very commonly used. And based on this ideology of the flow chart, we are able to quickly design, even a very complex system into breaking it down into smaller subsystems. And I think as engineers and scientists, what we really want is to try to get the measurement data or results that we want. So I think LabVIEW allows us to really accelerate that development. We may not necessarily need to go down to very low level type of coding, but to be able to program the way we think, I think that is one of the strategy and key as well, as you can see on this slide over here. Now, just to share, this is a sample of the LabVIEW block diagram. Basically, block diagram means the code, okay, in the so-called it is graphical in nature, and besides that, sometimes it is called also the data flow based G programming language. Okay, LabVIEW for graphical programming language, and one of the nice things I really like is that it is able to do parallel processing or concurrent task execution, which is one of the very neat things to have, to be able to do. So this is just a quick snapshot of a simple, or rather not simple, rather a block diagram, graphically presenting the codes in the LabVIEW form. So moving along, besides that, I think one of the strengths also for using LabVIEW is that you are able to quickly create very professional user interface, or called GUI, GUI. Yes. So and it is based on the very simple concept of drag and drop, where there are controls, indicators, and so on to help you create very specific tests or specific user interface that you want to for your own system, to operate your system. And besides that, there are collections of a large suite of available tools and libraries in LabVIEW, which we can utilize. Moving along, actually LabVIEW was beginning built by the father of what we call the father of LabVIEW, Jeff Kadotsky, from NI. He's the co-founder of National Instruments in 1976. So at that time, I think they created LabVIEW with the purpose to connect the PC to instruments, or to do data collection and measurement through the use of the GPIB bus, general purpose interface bus, which I think you still see some of them lying around. Yes, still being used, but probably less. And it allows the NI hardware to connect to hardware such as digital oscilloscopes, function gens, and so on, so-called the box instruments. Yes. So in this slide, I think what they're trying to show is that LabVIEW allows us to visually understand our data. There are a lot of built-in signal processing tools, toolkits, analysis, mathematical functions, and so on, ranging from, you name it, such as FFT to wavelet to time series analysis, and so on. So all these are available in LabVIEW. Now, moving along in this slide here, now, we don't necessarily need to discard our existing codes. Maybe some of you are, say, Python programmers, or you write your codes in C++, C, or .NET, and so on. We can still integrate these codes in LabVIEW as well. So there's a possibility you can do quite a lot of interfacing with the LabVIEW itself, which is pretty neat as well. So there's provision for that, to integrate your existing codes with LabVIEW. So in this slide, what I really like was the idea or the illustration of this thing called the ecosystem built on the NI platform. So to me, I've been using LabVIEW for many years now. So in the community, there's a large number of LabVIEW users out there. Okay, so there are probably, as you can see, some of the numbers are shown here. There are also forums, many forums which I frequent to use as well. I go to things like LabVIEW or the NI forum. LabVIEW is an independent forum done by the maintained by the community, and of course they also have the NI forum. There's a support networks, and sometimes you can see over here there are many. There are the technical support are there. There are engineers and so on. And besides that, with the user community, we also have students who are actively using LabVIEW. Okay, so often I tell my students that some of the questions that you probably wanted to ask, right, are already being answered in the forum, because somebody also have the similar or even the same type of questions that you probably would want to ask, and it has been answered in the forum. So that is quite neat, especially the user community. So for me, I also have opportunity to interact through the forum with the users, the top-notch users of LabVIEW, say in the Austin site in US, where they have the CLA or the CLD people, which I will explain what they are. Alright, so moving along, for LabVIEW certification, for myself, as a professional instructor, and at my institution we have a LabVIEW Academy. So we entitled our students to be able to attempt the certification program. Now many students tell me that after they obtain their certification, it is value add to them, because certification means that we can always tell people we are good in certain things, but you know, how do we know that? How do we prove that? I think these days there are a lot of certification badges out there, not only just NI, but of course over here we're talking about NI certifications, but there are many other types of certifications. So there are 3 levels of certification proficiency. So you have the LabVIEW Associate Developer, you have the LabVIEW Developer, and also the LabVIEW Architect, which is the highest level of certification offered by NI. And quite so far to date, I have the opportunity and privilege to train many of my own students to obtain their certifications, and they are pretty happy about it. So moving along to the introduction of the software. Now earlier I mentioned about the foundation of this LabVIEW really hinges on this virtual instrumentation, which I mentioned earlier that the father of LabVIEW, Jeff Kudowski, initially created the LabVIEW program mainly for the interfacing of that LabVIEW from a PC to a box instrument such as this through the use of GPIB. And of course there are certain advantages to use PC-based technology, which we can see shortly. Now the foundation of the use of LabVIEW or the virtual instrumentation really hinges or leverage on the COTS, the commercially off-the-shelf PC components, and then the software becomes the instruments. So basically, as we know, the Moore's law, yes, that states that the computing or the processing power for computers will double every 2 years. So nowadays, it's pretty phenomenal that we can even have artificial intelligence on an Intel chip, for example, chipset. Yes, because of that phenomena of the very high performance, high processing power. So I think for LabVIEW itself, pretty much that LabVIEW unlocks the power of the instrument and data acquisition hardware by really capitalizing on the strength of the PC industry. For example, your Intel, your processor and so on. And abstracting the redundant circuitry. So basically the software, as the software becomes more powerful, and so it hinges on the hardware development as well. The whole entire PC technology, which is so important. And then it makes the software becomes the instrument in a nutshell. So before I move on, let's briefly share about the LabVIEW. This is what you would see if any of you have your LabVIEW. Maybe we can just launch our LabVIEW to have some hands-on here. So we can see that the LabVIEW has this thing called the front panel, which you can see, and also the block diagram over here. Yeah, the block diagram is shown in this white space here, and the front panel is the one shown in the gray space. So basically your LabVIEW front panel is the part where you will place or design your graphical user interface, whereas your LabVIEW block diagram is the part that when you put in your code. So a VI stands for a virtual instrumentation, and it encapsulates all these three elements, including the icons and connectors. So how do we create the LabVIEW front panel? So what you do is pretty simple. You can on the control palette, you can right click to create a front panel, as you can see over here. So what is illustrated over here is a simple front panel of a waveform chart. Okay, so maybe I think it's a good time where we can work together to create some front panel objects. Okay, so I'm going to switch over to my LabVIEW part, and perhaps at the same time I will take the opportunity to pause this recording first, and I will leave the second part of the recording for the hands-on portion. Alright.